Okay, hi all. I am Yvon Jegou from INRIA in France, and during this talk I present the Contrail virtual execution platform, which is one of the main components of the Contrail software stack. In the first part I will present the Contrail project and how the VEP is integrated in this project. Second part is about the details of the virtual execution platform and how service level agreement and the derived execution environment are handled in this software stack. And then I will present the integration or the support of OpenNebula in Contrail. The Contrail project is about federated clouds and the support of heterogeneous infrastructure as a service providers, and with support for service level agreements mainly. And the major challenge here is the integration of resource from multiple providers. So in Contrail, the federation layer is seen as a portal for the user, where users submit application. And the federation layer is in charge of finding resource on different provider, selecting provider, and finding the best provider which can run the application. So the service level agreement appear here because in the user can specify restrictions on the way resources are provided, maybe about performance, security, etc. Okay, the Contrail project must implement elasticity in order to really implement the pay-as-you-go model. Only resources that are necessary for the application should be allocated and freed as soon as they are not necessary anymore. Contrail also needs to support many providers, and so to be very scalable, we have to implement a scalable software stack. And another constraint was about interoperability and portability. Interoperability with other implementation. So you'll see that we support some cloud standards which have to be enforced now. And I will not speak about security, but we also support federated identity model and authorization. So VEP in the Contrail software stack happens to be a component which is in between the federation layer and the infrastructure as a service layer. In fact, it is the VEP is in charge of receiving the requests from the federation and help selecting the best providers. In fact, here we have one VEP component per provider. The federation is a single component which speaks to multiple VEP. Normally, we should have one VEP per provider. And in fact, this component provides a high-level interface to the federation for application management, because this way, through VEP, federation always sees the same model for us, and it's doesn't need to be aware on the different IaaS offers. VEP also integrates service level agreement support. One of the reasons is that maybe the provider has no service level agreement support, and in this case, VEP can integrate the negotiation part. Even if, for instance, Amazon has no real service level agreement negotiation, we can still model service level agreement through the gold VM, platinum VM. But if a user asks for a strong security, in this case, the VEP, which is in front of Amazon, will tell there's no security or the level of security is weak. Okay. In fact, the VEP is in charge of receiving description of the application of the user from the federation, and then VEP is in charge of all the steps necessary to deploy the application on the IaaS layer, resource provisioning, elasticity management, and also something which maybe is not supported by all providers. For example, taking a snapshot of the application and saving the snapshots. The VEP participates to the provider selection through service level, to support for service level agreement mainly, and it is also in charge of feeding monitoring data for SLA enforcement, for instance, and also for the federation. Federation needs to be aware of the step reached by the application and if the application stops, etc. Okay, so and we are using a publish-subscribe bus inside Contrail, where we publish all information necessary to other services. But as for instance, OpenNebula does not publish monitoring data on such a bus. In fact, VP is in charge of getting monitoring information from OpenNebula and publish it on the monitoring bus. VP is in charge of adapting the level of monitoring provided by the offer to what is necessary to the Contrail layer. As for service level agreement, here in this picture, it's shown as a single component. In fact, it's not really a single component. It's a distributed service which is partly at the federation side and partly at the provider side. The part of a service level agreement depends on the federation, because inside it we can have provider selection. You can try to negotiate the same SLA with multiple providers and select maybe the best price or maybe the best performance, because this is part of the negotiation. And okay. But now during SLA negotiation, if, for instance, the user wants to have guarantees about resource provisioning when the application is deployed, this service has to be offered by VEP, which is in charge of allocating resource. So if the user negotiates the deployment of some application with the federation, and federation negotiate this application with some provider, it must in some case, it must be sure that it can deploy the application before it deploys it, because we don't accept the deployment failure. This must happen during the SLA negotiation. So VP provide the support for such a test without deploying the application. To have a in fact, because it is at SLA negotiation, during negotiation, maybe there are resources available, and when the user, in fact, commits, the resources are not available anymore. This can happen, but this is part of negotiation. But in this case, when the user signs the SLA, accept the SLA, in this case, VP will tell there's no resource anymore. It is not considered as a failure. It's just a negotiation that doesn't happen to succeed. In fact, and now, once the resources are allocated, the way once we have negotiated SLA, it is necessary to deploy the resource. Okay, the deployment process for the resource, allocation process of the resource must be aware of what has been negotiated in the SLA. For instance, you could negotiate to get 50 VMs inside the same cluster or on the same physical machine connected to the same high-performance network. And so resource allocation must be aware of what has been negotiated to SLA. And as I will show later, the negotiated SLA are translated in a kind of virtual platform description. That's the name, virtual execution platform, which this virtual platform integrates all the terms negotiated in the SLA. I will show later. So VEP has been deployed in the context of Contrail, but we have deployed it in such a way that we can use this service as an independent service. We don't need to have the SLA layer or the federation layer to exploit VEP. To be used as an independent services, VEP provides a RESTful API, so you can script deployments. And also, it can be exploited just through a simple browser, through HTTP. And VEP manages the application as a whole. It's not like OpenNebula, where you need to make multiple requests. Each request deploys one VM, or etc. Here, the idea is to manage the application as a whole. One of the reasons is that the SLA terms are about the application, are not about each individual feature of the application. If you have a term that says all VMs are on the same cluster, it's not a term that you can express on each VM independently. That's the reason why VEP is about the whole application. And for portability, because we have portability or interoperability in mind, the application, VEP applications are described using the standard OVF format, which is used by many companies like VMware, IBM, and where we already have a lot of applications stored in OVF marketplaces that you can get from this marketplace. And normally VEP, as VEP supports standard OVF, you can get the OVF from a marketplace, and it should be deployable on VEP without any modification. So an OVF application, an OVF package, in fact, describe a distributed application made of, I would say, virtual machine or containers, and shared storage, and networks. And it describes the connection between which machines are connected to which network, etc. The OVF also integrates rules for configuring the VMs or the containers, and also deployment rules, maybe sometimes placement rules. And it also integrates means to contextualize the virtual machine through what they call product sections. So these are information that are passed to the VM when they boot. Okay, VEP can exploit OVF application marketplace. Mainly, if you use a web browser, you click on the web and you find your OVF, and you import it on your browser, and you export it to VEP, and it should deploy nearly automatically. So, a typical life cycle of a VEP application. In fact, it needs to handle the virtual machine images, which are sometimes stored in external files. Configure the application, because the OVF is a bit, it's a kind of template. Maybe you need to say how many of each VM template you deploy, for instance. Specify the execution environment that's linked to the SLAs. Evaluate the resource needs and allocate all these resources, contextualize, deploy, and later manage elasticity. And VEP, because of SLA, also support advanced reservation of resource. You can tell I will need 100 VM tomorrow. This is because of SLA mainly. And through a constrained execution environment, we have support for the service level agreement. In fact, a constrained execution environment for VEP is a translation of the resource that have been negotiated during a service level agreement. And in fact, it is represented as a kind of virtual cluster or infrastructure, where you have a resource template for VMs, for storage, for networking, and constraints for resource allocation. Constraints on the VM, on the networks, and things like this. Our constraints are about localization, for instance, the countries, or affinity, like this VM and this VM must not be on the same cluster, for instance, or must be. Also about protection, security, performance. And then the idea here is that the OVF application is deployed inside this environment. Each virtual system of the OVF, for instance, is mapped on a resource, on virtual machine template of the virtual execution platform. And during resource allocation, all the constraints which are applied on this template are are respected during allocation. In fact, the CEE, you can have ready-to-use CEE, but kind of CEE, you can have it on Amazon. You can have a big cluster from Amazon. This is described in XML. We can use a lot to define their own CEE. And also in the Contrail project, they can be derived from the SLAs. So an example of CEE here, you describe a virtual cluster with 2 models of VM, large and small VM. Yeah? And the constraint here telling that all of these must be located on the same cluster. And you have a OVF descriptor. We derive an application where, for instance, we have 3 instances of the Apache server. Okay, we map this virtual resource on the virtual cluster, and then we got what we call allocation slot. In fact, after this mapping, we have the list of all resources that need to be allocated for the application. Because all the resources have to be allocated in one shot, we don't support, we don't allocate half of the resource and say for the others it fails. Because FLA, it must be allocated in a single shot. Now VEP and OpenNebula, the first implementation of VEP is on OpenNebula, where this section becomes VM images, virtual system can become VM templates, etc. For resource allocation, OpenNebula has no support for SLAs, so we have developed our own resource allocator, which is aware of all the terms that can be negotiated in SLAs. And also for monitoring, we need to adapt the OpenNebula monitoring to our publish-subscribe system. So we have an external service which is configured from VEP to push monitoring data. We have to improve VM image management because it's a bit expensive. Because to get VM image from external files, to build a VM to build the image, to export them to OpenNebula, sometimes we copy the image 2 times, and it's a bit expensive. And in the future, we need to support application snapshot, which is not currently really exported by OpenNebula. It's in libvirt, but not exactly in OpenNebula. Okay, VEP supports OVF standard, and the VEP API is conform with the CME API published last year by the MTF. It's just a kind of extension of CME API. And in future, we plan to make VEP server interoperable with CME clients to really implement the standard. And we have plans to support OCCI in the near future. It's a kind of requirement from the AGI. AGI UK wants they are ready to test VEP, but we have to interact with their server through OCCI. And we would like to use CDMI. Yes, CDMI because there's not so many implementations of CDMI, but they have nice features about caching of VM images, things like this, to reduce the cost of image management. But we are still waiting for a good implementation. VEP software, we have released a version this month, and it integrates the RESTful API, CEE support. It's available on this website, and full support for CME is planned for next year. Okay, so in fact, the conclusion here is that through VEP, we provide means to deploy complex or whole applications on OpenNebula infrastructure as a service. So this ends my talks. This is the Contrail consortium. Okay, and if you have any question about VEP and Contrail.
How flexible are the SLA definitions?
Yeah. Currently, we are using SLA at SOI, what part of the code developed during another project, SLA SOI. And so it's flexible because it's a kind of template, but you need to implement the negotiator. And normally they are conform to WS agreement model, but it's not exactly the same model. But the problem is mainly in the negotiator. You have to write it because each term has to be have some Java code behind. And so currently we negotiate placement, the size of the VM, some standard things, but not huge things.
The reason why I ask is in certain cases you might have legal requirements that you can't put your data onto a public, say, Amazon cloud, and you want to keep your data internal.
Yeah.
So if it's flexible enough to be able to
Yeah.
take the different use cases into account.
Yeah. Okay. The question is about placement of data. Yeah. And this the localization of data term is currently implemented in our model. And if you tell us, I don't want the data to go to China, we guarantee that it doesn't go to China. Okay. This is a typical term which is implemented because it's not so difficult to implement. Yes. No. Yeah. Okay. There was a move to OCCI at some point, but in fact the first implementation. Okay. For some reason we implemented directly on the OpenNebula API and not using OCCI. I think OCCI was not moving fast enough at this time, and then the next step would be OCCI. But now we have a kind of requirement from one of the partners that they want to have support for OpenStack. And so currently we have an implementation on OpenStack, but not through OCCI.
The second component is Rocky.
Yes.
It's close to OCCI, and they have drivers for OpenNebula. And they think they also have drivers for OpenStack. They have different drivers for OpenStack.
Yeah. Okay. So we have people asking for direct support for OpenStack. Okay. It's not so complex once you have OpenNebula. Okay. And OCCI now is because EGI. Okay, so OCCI could have been the third step maybe, but now we have negotiation with EGI UK, where they tell us you can install VEP on our infrastructure, but we want you to interact using OCCI because they have. Because they have machines on the OpenStack, I think, on the OpenNebula and maybe CloudStack. I don't remember exactly. But they want to give the same API for the users, so the user don't need to know OpenNebula. And so they have installed their own OCCI server on all this IaaS with exactly the same API. So it makes them transparent. They ask us to speak to this OCCI server. But this is standard OCCI except for a few attributes.
How, in context of OVF, how do you define the contextualization as well? I mean, because I understand that you have a component that speaks OCCI and to submit the virtual machines on OpenNebula or the cloud management platform. How do you solve the contextualization at the time of the virtual machines?
OVF defines, I think, 3 means for contextualization. One of the means is CD, ISO CD that is mounted at boot time, which is supported by OpenNebula. And so we have means to generate this CD. From OVF, we know how to generate the CD because it's a list of key value and files, yes, that are defined in Open. Yes, so we support this means. Yes, but the VM have to be aware of the. Yeah, okay, of course. But normally, the OVF corresponds to what is in the VM image. It's the responsibility of the user. Okay, so the first version is, we have got a rather stable version running. You can test it.